This is the third lecture for Unit 2. It covers average atomic mass. For this lecture, you're going to want a calculator and a periodic table handy. So there's two types of averages. There's a simple average and a weighted average. A simple average assumes the same number of every object. A weighted average takes into account the fact that we don't have equal numbers of all objects, and since we don't have equal numbers, we shouldn't count each one as important. So a simple average is probably what you're used to doing in math class. Sometimes it's called a mean. And so you just add up all the items and then divide by the number of them that there are. So let's do a couple of examples here. A student takes 5 exams and scores 86, 48, 97, 64, and 72. Calculate their average test score. Okay, so what you want to do is you want to add up these 3 numbers. Oops, let's get a pen here. Okay, add up those 5 numbers. Okay, so I'm going to add 86 plus 48 plus 97 and 64 and 72. And I add those numbers up and I get 367. Okay, and then there's 5 items, so there's 5 test scores. It tells you right here 5 exams. You divide that number by 5 and you get 73.4. Okay, so that right there is what's called a simple average. Okay, that will be our answer. So let's do one more of those. Okay, so here's another problem. There are 3 isotopes of carbon, carbon 12, 13, and 14. And let's calculate the mean of that one. Okay, so here are our masses, 12, 13, and 14. So we add those 3 numbers up, 12, 13, 14, and that gives us 39. We divide by 3, and that gives us 13 for our atomic mass units. But if you take a look at carbon on the periodic table, okay, carbon has an atomic mass of 12.01. And so you can see we obviously didn't just take the simple average of carbon and put the mass on the periodic table. In fact, most of the carbon in the world is carbon 12. So as we're going to see, we're going to do the simple average, and that's what's going to take it into effect. Take it all into account there. Okay, so to calculate the weighted average, since not all isotopes of an atom are present in equal proportions, we must use the weighted average. If we didn't use the weighted average, then you would get numbers that were incorrect. You would get masses that weren't really representative of what's out there in the world. And when we go on to do our more advanced chemistry calculations later this year, you would get the wrong answers. So what you do is you multiply the atomic mass of each isotope by its abundance, expressed as a decimal. Now, oftentimes this abundance right here, okay, that abundance is given to you as a percentage. So if it's given to you as a percentage, all you have to do is take the percentage and divide by 100 to get the abundance as a decimal. So, copper has 2 isotopes. Copper 63 with a mass of 62.930 atomic mass units, and it has a about a 69% abundance. And then we've got copper 65 with a mass of 64.928 atomic mass units, and then about a 31% abundance. So that's the information that we're going to use. Now, if they did not give you these atomic mass units, right here, let me circle them. Okay, if they didn't give you those numbers, you would just use these numbers to act as the masses that you would multiply. Okay, so let's go ahead and work on solving the problem. So let's do the copper 63 first. So we've got the mass, 62.930 0.30, and I want to multiply it by this abundance turned into a decimal, this percentage abundance. So you take the 69.09, divide it by 100, and that's what you get, so 0.6909. Okay, and I use my calculator and multiply those two numbers. And for right now, let's just take everything to 2 spots after the decimal, and I'll teach you later in the school year how to round things properly for a science class. So there we go. We got 43.48 atomic mass units. And we do the same thing for the copper 65, so 64.928. Change my percentage to a decimal, 0.3091. Multiply those two numbers, 64.928 times 0.3091. And now I get 20.07. So you see it's 0.069, round that up to 0.007. Okay, so next what I'm going to do is I'm going to take, oops, let's undo that thing. Can I undo that? I can't. All right, let's take those two numbers and add them together. Okay, so we've got 43, I'll rewrite them since I accidentally drew all over them. 43.48, 20.07. I'm going to add those two numbers up. 5, carry the 1, 5 point, and then 3, 63.55. And we always want to include our units, so that's atomic mass units. There we go. That's a better box. Now go ahead and check copper on the periodic table. And your answer should be close if it makes sense. And in fact, you do see that on our periodic table, copper has a mass of 63.55 atomic mass units. Okay, so atomic mass is the average of all the naturally occurring isotopes of that element. And notice we said naturally occurring, so they're not taking into account anything that's man-made in the lab. Okay, so just the ones that we find out in nature that you would typically deal with. Okay, so let's do another problem. We've got 3 natural isotopes of carbon, carbon 12, 13, and 14. And if you take a look here, you've got a table of information. Now, you don't necessarily need all the information in the table. And some of the information's even repeated. So like this right here, that's nice. They tell us that about the nucleus, but we don't really need the information. These two columns right here is just the same information twice. You see the 12 and the 12, and the 13 and the 13. So these are the masses that we will be using. And then here's our percent abundance in nature. Okay, so let's go ahead and take these numbers and divide by 100 and get them converted. Now, be very careful with these small percentages. Use your calculator to make sure that you get the percentages correct. Okay, 0.01 divided by 100, okay, is 0.0001 for your abundance expressed as a decimal. Okay, and then we're going to go ahead and add, multiply it times the masses, and then add these numbers up. So let me change my pen color again here. Something that will stand out for us. All right, so 12 times the 9.889. Okay, so I'm going to multiply these two numbers together, and with that I get 11.87 when I round it to 2 spots after the decimal. And I'm going to do the same for carbon 13. Okay, and that gets me 0.14. And I'm going to do the same thing now for carbon 14. And that's going to get me a really small, a really small number. Okay, and that's okay. Go ahead and write the whole thing down, because if we were to round it to no spots or 2 spots after the decimal, we would have nothing there. So that's fine. Add those 3 numbers up, and you get 12.01 atomic mass units. And again, check out your periodic table, and you should see an answer of 12.01 atomic mass units. Now, for this assignment, you do need to show your work. It is on paper to make it a little bit easier for you to do the math. Sometimes you're asked to calculate the simple average. Sometimes you're asked to calculate the weighted average. So read closely to what the question is asking. Okay? And note that the answer won't come out to exactly what's on the periodic table in every case, but it should come out to close to what's on the periodic table.